regarding engineering, natural sciences, and also economics and social sciences. The university has 8 faculties with more than 20,000 students and more than 1,200 academics. The Budapest University of Technology and Economics organizes the Competence Fair in order to provide the researchers, provide the academics a forum to meet, to build connections, and to engage in professional discussions, scientific discussions that potentially lead to Horizon Europe applications, joint Horizon Europe proposal submissions, and other types of cooperation. We organized the first Competence Fair last year, and the event attracted more than 200 viewers from more than 16 countries. Now I would like to welcome you all in the room and all of you who are following us online via the stream on YouTube or on Facebook. This year, we prepared a very interesting program for you, covering very important and relevant research domains in the European research area. The research areas we are going to cover in this event are advanced materials, next generation computing and data technologies, citizen communities, health technologies, new tools and solutions, clean and healthy air, water and soil, energy, smart and sustainable transport and mobility, and disaster-resilient infrastructure. You are going to listen to presentations of BME researchers on their specific research area, their research domain, and they are going to highlight their achievements, they are going to highlight their results, and they are going to introduce the competencies and the skill areas they would like to build partnerships and find consortia and find collaborators for Horizon Europe applications. Now I'm going to present you the BME Competence Map, which is a very important platform for building connections within the researchers of the university and external collaborators.
Mert az internet kegyetlen. Na most, ha nem vagy felkészülve erre, akkor viszont rossz munkát választ.
Usually, the presenters are not very happy if the audience is using the mobile phone, they are searching for something, they are clicking on links on their computers. But now I would like to encourage you to use your mobile phones, use your laptops, use your computers, and please go to competence.bme.hu. In this hyperlink, you can find the competence map of the Budapest University of Technology and Economics. There are different types of competence maps existing in different European universities and research institutions. The Budapest University of Technology and Economics competence map was launched in May 2022, and currently we have 152 research groups and more than 440 researcher profiles on this competence map. Why is this competence map unique? Why do we find it a platform that stands out of the crowd in our view? We have a high number of profiles available. We have a lot of research groups appearing on the competence map. We have a lot of researcher profiles. We have a great pool of potential collaborators for you to find on the platform. We do not only offer competence, we offer also value propositions. So we are not only showcasing what we do, but we would like you to know what we are offering, what we can bring into a consortium. We are supporting the Horizon Europe Partner Search through the competence map. I am going to show you which features are used for facilitating the partner search. We are also showcasing various dimensions of the competencies and the achievements of our researchers and research groups. And what is very important, this competence map is a platform we are constantly developing, we are constantly uploading new data, we are constantly adding new features in order to make this competence map a platform that is easy to use, that is enjoyable to use, and that is providing relevant information for our future partners. On the screen, you can see a research group profile page. Our intention is to provide our researchers a mini website where they can showcase their achievements, they can showcase their publications, their relevant projects, the patents they have. So all these activities that show their scientific excellence, but the researcher group profile offers more than that. We are showcasing also the partner search offers of our research groups. So when you go to one of the research group profile pages, you can find there the expertise offers that specific research group provided and prepared for a specific Horizon Europe call they would like to join they would like to find the consortium for. This is very important for us because, as I mentioned, the intention, the aim of the competence map is exactly to foster these types of collaborations, these types of cooperations. In the researcher profile page, as I mentioned, we have 443 researchers currently on the competence map. In the researcher profile page, we provide information about our researchers, a personal introduction, also the scientific publication, everything that the researcher finds important to show for an academic audience, for an industry partnership. So we offer them the possibility to introduce themselves from this perspective. It is very important to highlight that we are not only offering text, we are not only offering information in sections, in words, but also offering pictures, also offering 3-minute introductory videos of the research group. So we would like to provide this comprehensive portfolio of activities that show the researchers' excellence at the Budapest University of Technology and Economics. Very important new feature of the competence map is the laboratory infrastructure section. In this section, we are showing our potential partners, whether they are academic partners, whether they are industry partners, what laboratory competencies and facilities we have. And we are showing this competence in a way that it would be easy for our potential partners to see what we can offer, to see the potential application areas of that facility, and to see what equipment and what research area they are covering. As I mentioned, the ambition of the BME Competence Map is to facilitate the Horizon Europe partner search. In order to support this function of the competence map, we introduced a new section which is called the calls, and this section refers to all the Horizon Europe calls that our researchers would like to offer some kind of an expertise. So if you go to the competence map webpage and go to calls, you are going to see a list of the expertise offers of the research groups of the university who are interested in participating in that specific call. As a European research funding advisor, I know very well how important it is and how time-consuming it is to search for partners, to search for collaborators, and this way we are going to make it easier for you to find a relevant partner for your consortium. Regarding the consortium search we are not only offering the information, the general information of the research group, but we are also offering an expertise offer, which is a tech flyer, basically. And that expertise offer you can see on the screen right now. That expertise offer shows the competence, what a specific research group can bring into a specific Horizon Europe call in a way that it is easy to understand, clear to see, and we would like to save time for the potential coordinators in order to, so that they could find the information they need in a focused format. We introduce user-friendly search options. We would like to engage our viewers. We would like to engage the visitors of the competence map in these partner search activities. So we are offering multiple options for partner search, and we are also offering some kind of a help, some kind of a personalized search option possibility in the competence map. We also introduced a new matchmaking options, which is unique in the competence map scene. And this also facilitates the contacting progress in the process of building a consortium or building a partnership. So if you find a research group that is interesting for you, if you find a competence that you would like to see in your consortium, then with basically one simple registration, you can contact directly that research group, or you can contact directly multiple research groups who are offering that specific expertise or who are presenting their competencies for that specific call. When we launched the competence map, one very important and interesting consequence of this competence map was that we started to see that the researchers within the university started to explore what other researchers in other faculties, in other departments are doing. Multidisciplinary teams started to formulate for a specific research area. Researchers who were conducting their scientific experimentations from different aspects on the same topic got together, and we, as the editors of the competence map, we facilitated this type of getting together. We already had 4 events focusing on a specific research domain. On the slide, you can see photos of the event that we organized around the batteries scheme. In that event, there were researchers from 5 faculties of the university, and very interesting research cooperations already started formulating. This is something we would like to encourage also with this event, with the Competence Fair. So in the specific sections, researchers from various faculties of the university are participating, and what is common in their research is that specific domain, is that specific area, but they are going to showcase different perspectives that in our hope will lead to very important interdisciplinary cooperations within the university as well. We are not only offering just competencies, but we are offering value propositions as well. So in this slide, you can see flyers. In those flyers, which are also uploaded on the competence map to the research group profile page, you can see the specific expertise of a research group on a specific domain. So the research groups identify what Horizon Europe keywords they find relevant for their research areas. And for those Horizon Europe keywords like health technologies, advanced materials, renewable energy, they are preparing flyers. And on those flyers, they are highlighting their specific achievements, their specific competencies regarding that Horizon Europe domain. So on the slide, you can see a research group competence flyer regarding health technology, and a research group competence flyer regarding battery technology. Our aim is to put a story behind these achievements, to personalize who are dealing with this, who are doing this research, why are they doing that research, what is their motivation, what they find as their biggest achievement. So we would like to encourage the partnership building also with these competence flyers, and we would like to show the people, the researchers, the stories behind the research domains with these flyers that you can also find in the research group pages of the competence map. We are actively promoting the competence map. We are going to different events, national events, international events, where me and my colleagues are introducing the features of the competence map. Usually I can say that there is a great interest around this type of activity. And with this activity, we are highlighting, we are emphasizing our intention, our commitment to cooperate with external partners, and our commitment to facilitate this cooperation as much as we can with various platforms such as the competence map. And regarding the statistics, we are very happy that this competence map attracts users from all around the world. We have, if we see the average user number daily, we can say that we have like 40-50 users per day, which is 40-50 visitors per day from all around the world, which is very, very important for us. And we already have partnership requests coming in from the competence map. And this is something that we are really proud of, because this is why we are developing this platform. This is the possibility we would like to provide our researchers and provide our future collaborators. So as the last slide of the competence map, our takeaway message, what we would like you to remember of this platform, which is, of course, the domain, which is competence.bme.hu, and the uniqueness of this platform, the uniqueness of this competence map, which is not merely a database, but much more than that, shows stories, shows videos, shows pictures, and facilitates the partnership building with various tools and activities. We would like to provide you, as our potential partner, an informative, engaging, user-friendly platform where you can find relevant competencies for your consortium or for any type of future collaboration with the researchers of the Budapest University of Technology and Economics. Thank you very much for your attention. Please enjoy the event. And I will now give the floor to our first presenter in our first section. Thank you very much.
Itt tegnap is késeltek, itt izéren. Mi a fasz?
Lenn akartunk aludni Malibu Beach-en, tudod, gondoltuk, hogy mondták, hogy hát leparkoltak ott, jó, majd jönnek, megbüntetnek, $60. Mondtuk, jó, semmi gond, visszajöttünk Kajáldából, ott volt a bünti a szélvédőn, mondom, semmi gond, azzal a lendülette jött a rendőr, azt mondta, hogy
így ugrott ki a kezed a zsebedből.
Can we go back? Can we go back to the... Okay. Ladies and gentlemen, my name is György Balázs from the Department of Construction Materials and responsible for the Competence Center fiber-reinforced polymers and fiber-reinforced concretes. Today I have two short presentations. First one is the new materials called Perficon, and the second one is a new reinforcement which is called CFCM. These are two inventions, and my group participated in the definition of the characterization of the mechanical behavior and structural behavior, as well as potential applications. You can see here the first part of the report about Perficon. You all know very well reinforced concrete as a structural material because all of you are most probably are living in a reinforced concrete building, or part of the building is made of reinforced concrete. And in the same way, you use bridges and flyovers every day for your transportation. In case of reinforced concrete, the reinforced concrete is a composite material and consisted of concrete and reinforcement. In this case, the new invention is dealing with about the new reinforcement. Sorry. Oh. Sorry. And the reinforcement, you can see the element of the reinforcement and the top left part of the diagram. This is a three-dimensional fiber, about 4 centimeters around, which is distributed in the concrete if we mix to them. The reinforcement is able to provide tensile forces because they are overlapped in the part of these loops overlapping in the concrete. You can see that this overlapping makes possible the transfer of compressive forces. And of course, the size of the overlapping is very important. You can see that in the top, the bottom right part of the diagram. So in this case, there is a material which has high strength in compression, and we mix generally overall to the material a system which is producing high tensile strength. This is very important. This material is very important for the future of reinforced concrete. You can see potential applications: buildings, bridges, roads, hydraulic structures, UHPC, ultra-high-performance concrete, SIFCON, I will give an example soon, nuclear applications, impact, 3D printing, and welding of concrete as well. It is a new expression. In the top of the diagram, you can see the flexural behavior of a reinforced concrete element made of this special concrete containing this special reinforcement, special three-dimensional reinforcement, and the concrete is called Perficon. You can see that there is a considerable flexural capacity and considerable deformation capacity. In the left part of the diagram, you can see SIFCON, which is slightly infiltrated concrete, a special concrete, where you put the reinforcement first, and you add the matrix, the mortar, the concrete to the reinforcement. In this case, we have extraordinary capacity of deformations reaching even 50%, which is absolutely not usual for concrete. In the bottom part of this diagram, you can see an example of potential application for nuclear concrete. In case of nuclear application, one of the intention is to reduce gamma radiation by increasing the specific weight of concrete from 2,400, and in this case, we were able to reach almost double of the density, 4,500 kilogram per cubic meter, by the special reinforcement and steel balls, which were also used previously, in previous decades, also in Hungary. They are nicely mixed, and there is no segregation, there is no problem of mixing. On the left-hand side, there is a very special application of an old concrete, and a special joint is made with a new concrete, and the overlapping of this special three-dimensional reinforcement makes possibility for the transfer. You can see here the list of advantages of this special concrete. Complete encourages fibers never fail by pull-out, but in tension, good workability, no balling, no segregation, homogeneity, homogeneous fiber distribution, isotropy, fibers without orientation, confinement, no cracking, and sustainability, indicating durability. The second part is of my presentation, short presentation, is carbon fiber reinforced cementitious matrix, which is not fiber reinforced polymer, because a polymer is substituted by a cementitious matrix, indicating a much better behavior in fire. Here you can see the reinforcement which you can produce in your company with this special technology on the right-hand side, and you can create even smooth construction automatically. If you apply this reinforcement in concrete, which is very important application, you can have an extraordinary bond between the reinforcement and the concrete. You can see the distribution of different reinforcement, metallic, non-metallic, and these new types of reinforcement, new classes of reinforcement that you can add in a fresh form to the concrete, cast in the element, and in a hardened form as well. You can see one of our test results here, a special application in a beam. At the bottom part of the beam, we applied this CFCM material in direct connection with the concrete, and there will no problem with this application, and good for the future. Here I would like to conclude my second part and also my complete presentation. For the second part, the advantages are electrolytic corrosion is not possible, compatibility to concrete is very good, very high, and this reinforcement makes the possibility for design in any form. These two presentations include two patents. The owner of the patent in the first case was Csongor Cintos, and in the second case was Ferenc Csurgai. And as I mentioned to you, that we were helping to them for the characterization of this material and application for the future. Thank you for your attention.
Welcome everyone. My name is Christian Ban, and I would like to give a short overview about the research and development field of material science and manufacturing research group from Department of Automotive Technologies. I try to give this overview through some examples from latest and actual research and development projects. In our lab, we are ready to examine properties of surfaces, surface layers, and local changes in microscale range. The first possibility to examine the compositional distribution of a surface layer of alloys by glow discharge optical emission spectroscopy. The last project was we examined the oxygen diffusion into the surface layer in an additive manufactured titanium, aluminum, and vanadium alloy, which caused by the heat treatment. And in this figure, you can see the oxygen concentration as the function of depth from the surface. In the same field, we had another examination which dedicated to determine the local deviation of strain hardening effect in a deep drawn part. This mapping was carried out with microhardness measurements in a predefined points. the predefined points of the deep drawn part. In the field of manufacturing processes, we had a project in which we developed a manufacturing process for the simultaneous cutting of different materials. In this case, it was a magnesium alloy with sintered steel inserts, and this was a complex project because it contained tool design and optimization of the manufacturing parameters, and another addition problem was that this manufacturing process was able to perform applying dry machining or a minimal lubrication. Because of the fire hazard of the magnesium, it was another problem. Therefore, we have to perform very serious temperature control in this process. In the field of advanced functional materials, we developed a laser cutting technology for amorphous and nanocrystalline soft magnetic alloys. In this development, we examined the effect of heat-affected zone on structure of the material, and the magnetic properties of the material. These types of materials at this time are in the focus because it's a potential substitution for the traditional core magnetic materials. Some of my colleagues had investigation in the field of hydrogen storage in alloys. They investigated the hydrogen absorption and desorption profile of amorphous and some lightweight alloys. The figure, the hydrogen concentration or hydrogen concentration versus the time was plotted, you can see here, and this was repeated in other temperature conditions. These alloys also in the focus nowadays because it has a very high volume capacity in hydrogen storage. And finally, I would like to introduce our new research and development direction, which is dedicated for the additive manufactured materials. At present, we examine the structural and mechanical properties of, here you see structural picture of the additive manufactured stainless steel, and the other material is additive manufactured titanium, aluminum, vanadium alloys. These samples are made by selective laser melting, and recently we examined the fatigue properties of additive manufactured titanium, aluminum, vanadium. Here in this figure, the Wöhler curve was plotted of titanium, aluminum, vanadium in both state, which is as printed, and the heat-treated state. I hope that this overview was successful for you, and thank you for your attention.
Hello everyone, my name is Ali. I'm a PhD student at Telecommunication and Media Informatics at BME. In my presentation, I will talk about AFA alarm. So there are some facts about aphasia. Aphasia is impairment of language. The person cannot or has difficulties to talk after getting stoned. So people usually cannot read or write easily with this disease or aphasia. For solving this problem or help these people handle these difficulties, we designed AFA alarm. It's kind of application, help these people with emergency conditions by making a call for emergency or health giver. Here is some statistics about this problem. Aphasia is not very problematic topic. Also, there is no exact number of how many people have these symptoms. And usually, or around 30% have this problem after having stroke. So usually, stroke is small spots in the brain. And when people have stroke, they have problems with talking. So it's hard to control tongues, but you cannot, people easily move their hands, but they have problem with moving their tongues or control it. Also, about 45,000 to 50,000 people have stroke every year in Hungary. What's AFA alarm? It's application, as I said, and from 3 countries, Austria, Hungary, and Portugal, helped each other to develop this application. What else? Okay, so the process of development, this project, lasted for 3 years. So this project started 3 years ago, and on the first year, we collected or analysis information about how we develop this application. On the second year, we started to develop the technical part. So we asked some people who has aphasia to help us, to give us a feedback about the performance of this application. And also, we asked older people above 55 years to help us, to give us feedback. And part of this project, we asked speech and therapist expert to help to build this application or project. So, in the first picture on the left, this is the background of the application. You can see it doesn't have any text, just pictures. So the patient just need to click on the icon, and the second page on the middle show up. So, and also it's attached with text-to-speech synthesis. So when a patient click on, for example, on the button, police, it will play, you clicked on the police button. So in the conclusion, according to the feedback of the users, we got a good feedback. As you can see here, one is the best feedback with the green color. So, for example, how clear is the meaning of the pictograms, and it was very positive, easy to learn according to the feedback of the users. And 3 labs in our university participated in this program, or building this application. And thank you for your listening. And I'm happy to talk about our project. Thank you.
Ladies and gentlemen, thank you for coming. My name is Balazs Lisi, and I'm a master's degree student here at the University of Technology, and I'm studying construction information technology. Today, I'd like to talk to you about a topic which has been around for a while, but has not been addressed at all. I'm asking a question. What is that engineering graduates lack as they finish university? We've asked this question from various companies who have previously hired from the university. Findings have shown that university graduates need significant improvement in their combined knowledge, their experience, and their soft skills. These are typically things which people learn by working in the industry over several years. The Department of Civil Engineering in the university has decided to act upon these insights and decided to develop a new training program throughout which they provide a practice-oriented course towards the students. This has resulted in the creation of a new subject at the university called Construction Information and Technology, throughout which the students are subjected to a practice-oriented course with new, innovative, and reforming teaching methods. Let us have a look how these skill gaps have been bridged within this new course and these new teaching methodologies. Let us consider combined knowledge first. The construction industry is a vast and interconnected network requiring close collaboration between different departments and requiring engineers to not only possess information in their own field of expertise, but to also be competent in fields closely related to their own. Which is why students studying the Construction Information and Technology program will not only obtain valuable information in the fields of programming and building automation, but they will also obtain relevant information in fields related to it, such as heating, ventilation, and air conditioning systems, as well as building electrical systems, thus providing students with a holistic understanding of how the industry works and enforcing effective interdisciplinary collaboration between departments. Experience is a thing which students typically lack as they leave university. The Construction Information and Technology subject aims to bridge this gap, which is why they implemented a rather practice-oriented teaching program compared to the traditional face-to-face teaching methods. By putting greater emphasis on project work, group work, and assigning a project week throughout the course, the students are subjected to real-world scenarios where they can learn and understand the implications and the possibilities of what scenarios can happen throughout the real world in their career and get first-hand experience in how to solve real-world problems. At last, the requirement for improvements in people's soft skills cannot be overlooked, which is why people who undergo the new CIT program will obtain significant improvements in their soft skills. The course offers subjects such as argumentation and communication, by which students will be able to communicate their knowledge and their ideas more effectively. And the course also offers an ELISA subject, which is more for the entrepreneurial types who want to create their own businesses. The ELISA subject offers students the ability to create their own business plans and develop marketing strategies. It also offers a week-long hackathon where like-minded individuals from various departments, from various countries, come together, collaborate as a team, and they form groups and startup companies throughout which they will develop a business plan, a marketing strategy, and undergo an entrepreneurship program throughout which they'll develop a business proposal and undergo a mock inventors forum in front of investors to stimulate how this would look like as if you had your own startup in the real world. I hope that enlightening you with this information will encourage other universities and other departments to realize the need to improve the teaching methodologies which have not been changed for a very long time. And we hope that by implementing these new practice-oriented teaching models, students will be much more successful in their further careers. Thank you.
Hi, welcome everyone. My name is Peter Pajkosi, and my field of inquiry is cognitive science. This field investigates how information processed by your brain leads to responses, communication, and any output, actually. And crucially, cognitive scientists think that during this process, there are important cognitive processes like memory, attention, and perception, which modulate this process. And people at my department are dealing with this interaction of these processes and how they lead to goal-directed behavior and pathology. And a newly formed research group, which I am the PI, investigates specifically the interaction between attention and memory. And I would like to speak a bit about our research interests and our methodology. Regarding methodology, we use eye tracking, which is a popular and well-known method. And it basically uses infrared illumination to find the center of the pupil and use this to infer where the participant is looking. And eye trackers can be used in laboratory settings and also in everyday settings, like for example during driving or shopping in a shop. And what can we measure? First, we can measure several parameters of eye movements, for example, duration of fixations and saccades, and where participants are looking and how long are they looking there. And we have other method which we are very often use. This is pupillometry, and this is basically the measurement of the diameter of the pupil. This is a less known method, but actually every eye tracker can do it because they identify the center of the pupil for gaze detection. But it's not optimal for pupil detection, and you don't need actually an eye tracker to measure the size of the pupil. So we are actually developing an easy to use open source pupillometer for our measures. And pupillometry is first and foremost the size of the pupil is sensitive to luminance, but we are more interested in mental effort. It is linked to level of mental effort, the pupil dilation, and also it is linked to the activity of important neural networks, which are related to attention and memory. So we are using this methodology extensively, first to investigate attention through fixation patterns. For example, we could show that fixation patterns are a reliable marker of implicit learning and attentional set shifting. And using pupil dilation, we could also show that the magnitude of pupil dilation during retrieving information which was previously learned is actually associated with the quality of these memories, the strength of the memory, how well practiced it is, and even we could show that pupil dilation is sensitive to previous encounter with a stimuli without a direct memory test. And finally, we also have data on the link between brain processes related to pupil size and the processing of uncertainty, surprise, and change in the environment. For example, we could show that during simple story listening of narrative stories, the pupil delays shortly when there is a significant change in the story, a narrative switch, for example, a new protagonist or a new location is introduced. So to sum up, pupil size and gaze location, gaze behavior are important measures of attention memory, and they might signal pathology in several psychiatric and neurological diseases. So our main plan and also our main offer for potential cooperation is how we can use this technology in the early diagnosis and detection of these diseases. But our results regarding the link between memory strength and pupil dilation make it also possible to use this technology in educational settings, and of course this technology and our knowledge might be important or interesting for any application where the online processing and online measurement of human attention is important. And the question mark is there to signalize that we are also open to any other kind of cooperation. Thanks for your attention.
Hello, my name is Csaba Horváth from the Department of Fluid Mechanics of the Faculty of Mechanical Engineering here at the Budapest University of Technology and Economics. I'd like to talk to you about our department, which is our bastion that is built on many strong pillars. Our department has many different research groups, and these are our pillars. Each research group providing a key aspect with regard to the research that we do and the way that we can help all our partners, be those industrial partners or research institutes. How can we do this, or what does the department provide? This bastion, what does it provide on our behalf? Well, it provides us with excellent research facilities, and with our vast experience, we're able to use the wind tunnels, the measurement rigs, be that hot wire anemometry, laser Doppler anemometry, particle image velocimetry, or microphone systems that we have, be that single microphone or phased array microphone systems that we have, in order to carry out tests on our specialized test rigs. In this aspect, I'd like to talk about a little bit later about turbomachinery test rigs, or other specialized test rigs, be those for our research or for your research, and in order to carry out the measurements we need in order to prove our theories, to check our thoughts, in order to see if what we're designing is good or not. But we don't only have measurement rigs that we can use. We also have simulation technology that we can apply. So we have many strong commercial codes that we can use in order to do CFD simulations, so computational fluid dynamics simulations. We can do many multi-physics types of investigations. And we have in-house codes that we've developed or further developed if we use an available code that's open source, in order to look at many specialized applications, be that mesoscale atmospheric flows, fire safety applications, or aeroacoustic simulations, and many interesting environments. Our pillars that I was talking about are these research groups you can see here. Our turbomachinery and our turbomachinery and acoustics research groups, which I'm going to talk about after this. And the other pillars that we have at our department: morphodynamics research group, atmospheric flows research group, aerodynamics research group, and nonlinear dynamics of interconnected systems research groups. Each one of these pillars has a leader. I lead the acoustics research group, and I'm a member also in the turbomachinery research group, and I'm going to talk about those a little bit more now. Here's a picture of a portion of our group. We're quite strong. We're almost 10 people, with the head of the department also being in our research group. He leads the turbomachinery side of the group. I lead the acoustics side of the group. And we work with many, many partners in the industry and around the world in order to carry out our research and investigations. What can we provide on your behalf? Well, with regard to turbomachinery, we're highly skilled in applying controlled vortex design methods and radial stacking techniques in order to achieve an aerodynamically suitable system which can do the performance with the restraints that you might have. So it can achieve the performance that you need, taking into consideration any restraints you might have. Why it would be important for you to work with someone with such skills and experience. We work with many, many small applications, be that something of only a few centimeters size, to something that might be a few meters in diameter, in many, many difficult environments. How does the turbomachinery group and the acoustics research group meet? Well, when we apply our measurement methods and our simulation methods in order to achieve high performance and good acoustic characteristics, we use our simulation and measurement techniques in order to develop all the different systems that we look at. Here you can see that we apply CFD and CAA, computational fluid dynamics and computational aeroacoustics, in order to look at the aerodynamics and then the acoustics of the various systems that we look at. And we don't only do this with simulations, we also do this with measurement techniques, as you can see at the bottom of the slide. With regard to counter-rotating open rotors, which some of you might have joined in to hear about, we've worked together with NASA Gillen Research Center in the past. We've worked together with colleagues in Ireland and around Europe in order to work on different methods in order to investigate counter-rotating open rotors. This is the test that we've worked with the most. That's why I'm showing you this one on this slide. And my students and I, my PhD students and master students and my colleagues together with me have developed many different filtering methods in order to separate the tonal and the broadband components of the noise sources of these turbomachinery systems. And we've looked at them using phase array microphone systems in order to localize the noise sources. It is our belief that if we're able to localize the noise sources, we'll be able to study them in more detail. When we study them in more detail, we'll understand them. Once we understand them, we can then set a plan on how to alleviate the systems from these noise sources and provide the community with turbomachinery systems that are much better with regard to their health and their future. Not only have we concentrated on aircraft engines, we've also worked with drones. And we're currently developing a drone test rig at our department that we'd be happy to show you and continue our research on with you. As I said, we have our pillars, and we're very proud of these pillars. If you're interested in any of these research groups, please take a look at our department's website or the competence map in order to learn more about us. Thank you very much for listening, and we look forward to working together with you.
Okay, so welcome everyone, and let me briefly introduce myself a little bit. I am Dorottya Szemere, and me and my co-author or research partner, Tamás Iványi, have been researching for almost 3 years to how we can integrate electric scooters or other e-mobility transport systems into urban transportation. As you can see here, micromobility is one of the hottest sector with startups and traditionally OEMs whom are developing new technologies and of course new transportation modes. But we have several other problems with this new type of mobility systems. For example, the users don't use these vehicles better, I mean, the good way. So that's why we would like to so our purpose is to identify several stakeholder needs, and that's why we use lots of research methods, for example, social listening and focus group methods, and we would like to build a QFD house with other colleagues from Serbia. And our main goal is to help the legislators make better rules and make a cleaner and sustainable city. And thank you for your attention. I was Dora Samara, so if you have any questions or if you would like to contact with us, you can find here my email address. And thank you very much.
Hello everyone, my name is Laszlo Szécsi, and I would like to talk about the e-diploma project. The e-diploma project is a Horizon project which is not a technical project. It's a social track project which aims to better society and not to develop new technologies. But we are a technical university, so what's interesting about this is that we are how we cope with, working with partners who are not technically minded people, but they are social scientists. And the aim of the project is to investigate disruptive technologies in education like virtual reality, extended reality or augmented reality, video conferencing, multiplayer group activities, gamification, and of course, the emerging challenge of AI. And the project aims at creating a new platform, showcasing new technologies, but mainly to provide best practices and policies for policymakers on how to make the best use of these technologies. And the project is in the first year, so we've been examining current e-learning ecosystems, and there is a so-called co-creation process, which means that we try to engage with stakeholders and experts, trying to find out what the challenges are and how really these technologies could be used. And then we develop a new online platform with course prototypes, and those course prototypes will be taught to students so that we can evaluate what performance, what outcomes these new technologies enable. And then, of course, at the end, we will need to arrive at some recommendations. So the consortium is, of course, from all around Europe, and there are 3 partners here who are technical partners. And the rest, they are in social sciences. So they would be experts in education, they would be experts in methodologies in evaluating these outcomes. And so we talk quite a different language, I would say, because, intentionally I display here a soup of abbreviations which refer to all kinds of technologies we are considering here, like how we can put all of this in the cloud so that the educational institutes do not need to have their own infrastructure for these tools, how users can be authenticated, how this can be integrated with existing educational systems, and of course, what kind of game engine technologies and what kind of graphics technologies can be used. So my research group in particular is concerned with graphics and games, so gamification is our focus here. On the other hand, the social partners here, they are interested in like the ethical aspects here, or we have to get ethics approvals for research, which we are not used to because we usually do not deal with people really, only machines. And we have to do analysis based on values and organize surveys, talking to experts and workshops. And hackathons are different for them than for us because we believe those are developing software, and they believe they are talking to experts. So we have to somehow match these together, and I believe this is a big challenge for the coordinator, the Spanish coordinators in particular, because they have to facilitate all kinds of communication between the partners so that we see eye to eye. And someone has to take the lead on saying what we need to do so that we can, find out what actually needs to be done in this project. So this is a big opportunity to do a social kind of project, but also a big challenge. So thank you very much for your attention.
So hello everyone, I'm Laszlo Gönci from the Critical Systems Research Group, and I'd like to introduce our research and challenges and opportunities of blockchain in industrial and business applications. So we've been quite active in this field since 2016 with a first focus on performance modeling of blockchain, and we have an ongoing cooperation with the Duke University on that. We are a member of the Linux Foundation in the Hyperledger project, where we have been mentoring 10 mentorship projects. We are leading the benchmarking tool of this project. We are a member in different working groups. We are active in standardization. We operate in a node, a blockchain node in the European Blockchain Network. We are a member of the Blockchain Coalition, and we've been quite active in the education, both at the university and in the professional field. And to talk a bit about how we see the challenges and opportunities of blockchain. So first, there are a lot of R&D and engineering aspects in which we are interested, like trustworthiness of the systems, the privacy of the data or the decisions, or the performability of the systems, security of the overall architecture, and governance issues as well. Main opportunities lie, of course, in the business model, where blockchain can support collaboration without the need for a trusted third party. This enables the creation of data sharing ecosystems, decentralized control for applications, and traceability for assets and information. And there are a lot of applications coming from the field of manufacturing, transportation, logistics, to energy supply or novel types of financial applications as well. So what we do in R&D in all of these fields? First, we are active in the verification and validation of blockchain-based architecture and system. We concentrate on measurement and analysis of Hyperledger Fabric, which is the major solution for consortium blockchain applications. We perform verification for smart contracts, programs running over blockchain, and fault injections to such smart contracts as well. From the more methodological side, we are active in requirement-driven design of applications, blockchainifications, so gradual turning of traditional applications to decentralized ones, and migration of business processes and rules over blockchain. From the more application-oriented point of view, we are active in the field of critical cyber-physical systems, cross-organizational workflows, and we have a cooperation concentrating on central bank digital currencies with MMB as well. From the technological side, we develop open source projects for benchmarking of blockchain applications, for creating applications out of business models, and to support zero-knowledge workflows, which is a recent development concentrating on collaborations when even participants don't know about the exact decision and control logic in the system. And about our ongoing projects and research interests, we have ongoing related EU projects concentrating on consulting and training services for SMEs in Hungary and in Europe as well. And we have 2 projects starting this year, one concentrating on the support of secure supply chains, supporting the analysis of error propagation and the integrity of embedded software as well. And another one where we would develop a component to support data veracity, so to evaluate data in the distributed systems and to support data sharing in data spaces. There, I would lead over the development effort of the project as well. And about our interests in new research projects, we are interested in trustworthy, decentralized or distributed systems, and also transforming existing systems to decentralized ones, cloud or edge-based data sharing and analytic services, and systems engineering and model-driven methods for blockchain applications. So thank you for your attention, and we look forward for collaboration possibilities.
Okay. Thank you for being here. My name is Tamás Kovács, and I will speak about our Horizon 2020 project called Smart for All. Smart for All is a big EU project in which BME takes part. Okay. In which BME takes part, and this project will end in December this year, and it is primarily a networking project, and it offers practical application experiments for various parties, including Hungarian companies, universities. And it is organized around a so-called marketplace as a service feature, which has a matchmaking service. It provides educational materials, and these practical application experiments are also helped by coaching services and business development services provided by the partners of the project. Actually, there are 4 Hungarian projects winning funding from this Smart for All scheme. This is a kind of cascading funding scheme. And POPLEC, or second project, is kind of flagship in the project because it is very successful. It is between a Hungarian partner called PCB Design and an Italian partner who they together developed a special measurement equipment for silicon devices. This practical application experiment gets mentoring coaching services in the technical field, business field, and also they work together with project members. BME, our department, is active in the technical and mentoring coaching field. I am the member of the so-called mentoring committee, which organizes and supervises this mentoring process, and typically 3 persons at the department works on this technical mentoring work. Yeah, also technical partners of the project, BME is a technical partner, get a possibility to do an internal practical application experiment through these services of the project, just to test the project itself from internally. This is a 6-person project, and it is a streamlined evaluation compared to external projects. And in this, only the project partner is funded, the other party is not. They need to invest in this project, and with this, they get a technology transfer from the technology partner. Or internal practical application experiment is with TIA Concept GmbH in Freiburg, Germany, and of course, the other part is BME MIT. TIA Concept GmbH is a company specializing in IO-Link standardization and development. IO-Link is short-distance, bidirectional, simple industrial communication standard, and it is very low cost, and it can provide sensors and actuators. And typically it is used to connect sensors and actuators to gateways which connect these to Ethernet-based field buses. Our department has a competency in clock and frequency synchronization, and in that in time-sensitive networking, which is real-time and dependent Ethernet. It is a new technology, and it is upcoming. And IO-Link must be moved towards this new technology, and this is how this project funded, this is the rationale behind the project, because BMMIT has the tools, software components developed here, while IO-Link doesn't know this thing, and we need to develop an IO-Link solution which can be used in these new technologies. This is how this project is funded. And currently the project is ongoing. We have initial results, and hopefully soon we will have a prototype implementation and TIA concept plans to standardize this technology. So they plan to push through it in the standardization project, and hopefully due to this we will have an IO-Link which is operational in time-sensitive networking modern environment. Thank you for your attention.
Hi, my name is Sofia Kugler, and very well welcome to the audience both in person and online. So today I would like to share with you some information about our Knowledge Center, for which I'm the director of this institution, the Knowledge Center for Water Science and Disaster Prevention. So what is our mission? Our mission is to bridge cutting-edge engineering methods in disaster prevention. We are in a close cooperation with both stakeholders and industrial partners. We are coordinating R&D and I activities, and we would like to enhance our competitiveness in those activities. So if you want to elaborate more information, you can find some information on our website. And we are working basically with industrial safety, analyzing fires and effects of explosions. We are working with environmental emergencies as well, like floods or earthquakes. And we have very large competencies in water sciences. So our activities, our research groups are working on the mitigation of risk for natural or man-made disasters. We are involved in early warning or emergency management, and also in post-disaster reconstruction and damage assessment. I would like to highlight some of our expertise just in a nutshell, because we are a very large working group. We are working with extreme floods and assessing ecological status of our rivers. We work on large-scale water management and water quality research projects. We are working in the field of safe water drinking supply and efficient wastewater treatment or wastewater management. We also work with climate vulnerability, assessing adoption and sustainability. We are monitoring and assessing risk of both flood defenses and critical infrastructures. You may hear a lot of news about that in the latest news. Prevention and management of industrial disasters. We work with earthquake vulnerability assessment, with the protection of engineering structures, specifically focusing on historical monuments for seismic risks, and the design of nuclear facilities, how to protect them against extreme impacts. Impact of fire and explosion of engineering facilities is also in our expertise. and we also work with flame retardancy. So if you like any of our activities, please feel free to reach out to us. You can find more information on our website, and please send us just an email if you have any questions. So thank you for the opportunity, and thank you for listening.
Welcome. Hello, my name is András Vörös and I'm from the Critical Systems Research Group, and I will show our work in the field of resilient infrastructures, especially related to cyber-physical systems. Cyber-physical systems are those systems that combine sensor networks with embedded and cloud computing to monitor and control the physical environment. Such application domains are smart grid, smart city solutions, or transportation. In such domain, we have to gather data, and based on some computing and intelligence, we have to provide smart control. In order to be able to collect data, we need reliable integration technologies, and we also need, beside intelligence, we need fault-tolerant and algorithms for resiliency. And these are our core competencies at our research group. So in order, so with the help of all these technologies, we are able to control the physical environment, we are able to optimize the operation, and also to react to external events. And we are developing design methods and tools for CPS. So we are using various integration technologies for real-time distributed control. We develop various optimization techniques, data processing, and visual data analytics. And as my colleague formerly mentioned, we also develop blockchain-based solutions that are digital enablers for sustainable and resilient infrastructures. We also develop tools to support the fault-tolerant system design, and we also provide various analysis opportunities to evaluate the system architectures. We also develop verification techniques based on formal methods and also simulation to analyze both the software and also the system level behavior. We provide testing and integration testing for such systems. And also our core competency is to provide safety, reliability, and performance analysis, such as failure modes and effect analysis that are widely known in many industries. We also develop Markovian analysis tools and also complex numerical and deep probabilistic programming-based methods to evaluate the safety, the reliability, and the performance of such CPS. Thank you for your attention, and if you have any question or if you are open for collaboration, you can reach us at this webpage. Thank you very much.
Thank you. I'm Viktor Józsa. My presentation is entitled Atomization Makes Statistics Helpful Tools to Find the Needle in the Haystack. Actually, I would like to start with a quote from Queen Elizabeth II. At its heart, engineering is about using science to find creative, practical solutions. It's a noble profession. So in the light of this quote, I would like to continue my short presentation. About my research team, we are currently 8 with some fluctuations. And principally, we are focusing on applied research and also act as an expertise group for various industrial partners from small companies to big global companies, including names like GE, Rolls-Royce, Siemens, and so on. Atomization can be found in many fields. So the top left corner of the screen is not a CGI image and not from Marvel Universe and Star Wars. It is actually highly efficient molten slag removal and reuse technology to create some feedstock for the construction industry. Another application of atomization is obviously paint spraying, so you can see a lot of graffitis around the city. And I would like to highlight drone applications since in plant protection, it is becoming more and more relevant to do autonomous care. And in medicine, obviously, inhalators, if you have lung problems, you obviously faced with such technology. And last but not least, in transportation, and especially combustion engines, we have to atomize the liquid fuels to get small enough droplets. And actually, we create multi-million droplets within a second, and the scales doesn't allow us to just make a numerical simulation, and the physics are pretty hard to reconstruct. This is why we need measurements, and since there are many droplets, we have tons of data. What you see here is actually a rotary atomizer, which is a drum filled with a liquid with some holes, and actually some liquid jet is ejecting. So the first step is always data filtering. First one is to find some outliers to have a reliable statistical model fitting. And to do so, simple approaches like finding the outlier data in either the small and large sizes can help you. But furthermore, you need to improve to distinguish the physically meaningful and the physically meaningless part. It sounds nice, but its practical implementation is pretty hard. So. Therefore, in this case, you feel that there should be some relationship between the radial and tangential velocities. So this is why you can apply some filter based on the velocity ratio. Negative velocities can also be generated by some recirculation. So therefore, performing the proper filtering may somehow end up with significant data reduction, but highly increase your data quality. The next one is just to go ahead and find the trends and define a proper algorithm that helps you in generating a versatile platform, an automated one that helps you in processing large amounts of data and end up with meaningful scientific conclusions. Thank you very much, and I'm looking forward to collaborate with you. Thank you.
Welcome everyone, my name is Levent Tarác and I'm an assistant lecturer at Power Electric Department. In this short presentation I would like to present the FARCROSS European Union funded project. The FARCROSS project is in the group of bridge projects, and this is a 4-year project which started in 2019, and our goal is to facilitate regional cross-border power flows. And why this issue is important? Because if we see the energy system, we see the electricity system, we see changing in the producing side and also on the consumer side. So we have to develop our transmission system also. And in this project, we try to improve the power flows by hardware and software technologies and also some market optimization. As you can see, there are different demonstration areas in these projects, and VP5 and VP8 is important because in these VPs BME is involved. DLRH is about dynamic line rating, and OptimCap demo is about market optimization. If you are interested in the results and actualities, you can check the website and also LinkedIn and Twitter. In this presentation, I would like to focus on VP5 and its result. VP5 focuses on dynamic line rating, which is an effective tool if we would like to increase the transfer capacity of power lines. So what we do in this project, we install sensors on power lines, on phase conductors, and also on the structure, and we monitor the weather parameters and also the line parameters. And in this way, from the collected data, we can calculate ampacity and also line rating and also some health indexes on the power lines. In this project, four countries are involved: Hungary, Austria, Greece, and Croatia, and you can see that 8 power lines are involved. So what are our results in these projects? Dynamic line rating sounds easy, but there are really huge challenges. First challenge is which power lines are good for this technique and where to install sensors. So the first task was of BME was to define a sensor placement strategy and do SEG model, and we did it for all the power lines, and we found the critical points where to install the sensors. We found during the project that so many sensors and weather stations are needed in the project, so we tried to do some optimization and try to find a way how to reduce the costs. So we developed different algorithms. The first one is an artificial neural network-based conductor temperature model. The core of the model is to install sensors, and after 1 year we train the neural network, and in this way we can reinstall the sensors to different sections. The second one is a novel ampacity calculation approach. This is based on sensor measurements. This is a novelty because in the literature there is only available algorithms which calculates the ampacity from weather parameters. So in this way we can reduce the number of weather stations on the line. In this way reduce the cost. And last but not least, we have an icing alert system, which is really important because in the last 10 years there were more than 5 events in Hungary when tower collapsed and conductor broke. And we have an algorithm which can calculate from weather forecast the typical type of the ice and also the thickness of the ice and the mechanical load of the ice. So in this way we can calculate the preventive current and to heat up the conductor to prevent icing. Thank you very much.
Welcome everyone. My name is Máté Szibet from the Institute of Nuclear Techniques, and I would like to introduce you the Great Pioneer Project and our contribution to it. The nuclear industry heavily relies on modeling and simulation in the design, operation and safety analysis. But we observed that reactor physics courses all over Europe runs with fewer and fewer students. But, obviously the lack of skilled personnel may be a bottleneck in nuclear energy development, and also at a certain point may endanger the safe operation of the existing installations. So as a response to this situation, the Great Pioneer Project aims to develop and provide specialized and advanced courses in computational and experimental reactor physics, using innovative pedagogical methods to make these courses more efficient and promote student learning, targeting not only the graduate levels and postgraduate levels, but also young professionals working already in the nuclear industry and offering them the flexibility in learning what they need when they are already working. The consortium includes 8 universities from 6 European countries, and this is a 3-year project extended till next October and coordinated by the Chalmers University of Technology. So the overall concept is to offer courses in a hybrid learning environment, combining on-site and off-site students for the synchronous interactions, and also to introduce innovative pedagogical methods like the flipped classroom, so allowing an asynchronous preparatory phase in a self-paced learning for the background materials and jumping to more complex tasks with active learning during the synchronous sessions. So these active learning tasks include hands-on exercises, relying partly on computer-based modeling and simulations, where we can either use existing tools, either commercial or open source. Like in our case, the BME, we contribute with exercises with the OpenMC, open source Monte Carlo particle transport code. So the student can perform exercises with this code, including tasks like modeling our own reactor, or it can be implementing of algorithms in computing environments. Like again, in our case, it's mainly Monte Carlo methods and computation methods in radiation shielding, which we do in a MATLAB grader environment. Besides the computer-based modeling and simulations, the project rely on the use of 3 training reactors. Besides the AKR-2 reactor in Dresden, Germany, and the Crocus in Lausanne, Switzerland, it's obviously the BME training reactor, which is also included in the project. And we use this opportunity of having training reactors as well to couple measurements and simulations and perform simulations on problems which can be also measured in one of the reactors. Our course offering almost covers every field in reactor physics, starting from nuclear data through steady state and transient modeling till applications like radiation protection and shielding calculations, and also includes the 3 hands-on exercises sessions on the training reactors. We contribute our institute to several to several work packages, and we host the radiation protection and shielding calculation course, and obviously the BME training reactor course. For the first round of these courses, we really experienced a fantastic engagement, participation, and completion, both from the online and on-site participants. And all courses will be reoffered in 2023, 2024. So please, if you got interested, visit our website, and the registration for the first 2 courses in September and October has already started. Thank you very much for your kind attention. So my name is Máté Siebert from the Institute of Nuclear Technology, and I would like to introduce you to the PUMA project and our contribution to it. Nuclear, it's not changing, sorry. So my name is Máté Siebert from the Institute of Nuclear Technology, and I would like to introduce this PUMA project and our contribution to it. Nuclear reactors, while consume natural uranium, produce plutonium, which is a sensitive nuclear material and a highly radiotoxic component of the nuclear waste. Fortunately, it can be recycled, and in this way we can reduce the use of natural resources and the radiosity of the waste. the next generation, the expected next generation of reactors, so the generation 4 fast reactors, can support large quantities of plutonium and recycle it many times. Therefore, they offer the opportunity to close the nuclear fuel cycle and in this way increase the sustainability of nuclear energy. So this PUMA project, which is a large international project, aims to define different options for plutonium management in generation 4 nuclear reactors and evaluate the impact of the high plutonium content on the whole fuel cycle, the reactor safety and performance. So as I mentioned, this is a large international project from many European countries, with institutions from many European countries and coordinated by the French CEA. The BME contributes to the work package 1 among these technical work packages covering different fields of the fuel cycle, which is about fuel cycle scenario analysis. So what is this about? The objective is to cover a wide range of different options regarding the plutonium management. It can be the stabilization of the plutonium inventory or the minimization, or also it can be plutonium breeding. Breeding is required when a fast reactor fleet is built up after during a transition from the traditional light water reactor technology. In this case, we need to increase the plutonium content because the fast reactors use that as fuel. Then self-breeding or isogeneration is needed to stabilize the inventory because we do not want to have more plutonium than it is really needed. And the burning capability of fast reactor allows also to manage the legacy spent fuel stock. So from from the current reactor field, which remains from the current reactor field. So the fuel cycle scenario analysis task aims to investigate different fast reactor technologies with different options, different fuel compositions to show this kind of flexibility of the reactor technology for plutonium management. Concerning our task, we contribute with the analysis of several different reactor types and plutonium management options with these scenario analysis tools developed during the last decades. The one is the CITON scenario analysis tool developed in cooperation with the Center for Energy Research. This has a feature that it can support unlimited number of flexibly connected facilities of the fuel cycle, and it has other very powerful features like several options for the calculation of the composition of the discharged fuel from the reactor, including this fit access method, which was developed by our research group at the Institute of Nuclear Technology and is based on the cross-section parameterization based on the fitting on the fuel composition. Models for practically all the three major fast reactor technologies, gas-cooled, lead-cooled, and sodium-cooled fast reactors are available in the code, and also for MOX-fueled thermal reactors. And during the project, we plan to develop new models for burner fast reactor designs. And last but not least, we have also this JOSET fuel cycle scenario analysis tool, which is based on C++ object-oriented programming, was originally intended for a test bench of the fit access, but provides a very good opportunity for testing new features and providing quick scenario analysis tools. Thank you for your attention.
welcome everybody. I'm Tamás Varjú from the Institute of Nuclear Techniques, and today I would like to present you an overview of the EU-funded ECC Smart project and the work and contribution of our research team. So the ECC Smart project has 20 member institutes from Europe, China, and Canada. And its main aim is to develop a pre-conceptual design of a supercritical water-cooled small modular reactor. Supercritical water is widely used in various fields of the industry, but it has never been used as a coolant of a nuclear power plant. So our main plan is to use it because of its various advantages. In the planned design, this small modular reactor will have 290 megawatt thermal power, 25 megapascal system pressure, and 500 Celsius degree outlet temperature. These high pressure and temperature system can provide much higher efficiency of electricity production. This is the main advantage. On the other hand, it has some disadvantages. We have to cope with these high pressures and temperatures, and there is also some difficulties with the supercritical water as a material. On the right-hand side, you can see the design of the reactor vessel and the fuel assemblies. Here we have 400 fuel assemblies aligned in a horizontal way, and the core is divided into 7 stages, which are connected in a series, which means that the coolant goes through the core 7 times with a proper mixing after each to avoid hotspots in the core. Through this flow path, the coolant goes only in a horizontal way or upward, with which we can assure that natural circulation can be developed in the core in case of an accident. So BME contributes in 4 working packages of this project. The VP3 is related to thermal hydraulics and the safety of this reactor concept. We use the EPROS system code and the ANSYS CFX CFD code in this package, and we have performed various benchmark analysis, and now we are working on the fuel assembly, reactor vessel, and primary system models of this concept. VP4 is related to neutron physics. Here, benchmark analysis has also been performed with the use of MCMP, Serpent, and OpenMC codes. For this specific design, Serpent 2 and an in-house SPN code model is also being developed. Furthermore, in cooperation of VP3 and VP4, we have coupled EPROS Serpent, EPROS SPN and Serpent ANSYS CFX coupled models, and these are under development. In VP5, the method of the paired analysis is applied, and its main aim is to identify the most important phenomena and the knowledge gaps in this field. Finally, in VP6, the dissemination and communication, it's also quite important as part of this project. We have performed and we are still working on various publications. We participate in conferences and workshops as well. So as you can see, in this EU-funded project, BME has various and quite important contributions. We have participated in various benchmark analysis, and we are also performing various calculations for the specific design. And one additional thing which is quite important in all EU-funded projects is that a lot of our BSc and master students are also involved in this project, and they have a quite important contribution. So thank you very much.
education and training actions. The ENEN2 Plus stands of the largest and most integrative nuclear education and training efforts up to date. Attraction of excellent new talents followed by outstanding development through education and training, cross-cultural and cross-disciplinary activities are the overreaching objectives. A detailed insight into the European Union's supply and demand of nuclear human resources for power and non-power applications will be developed. This will include industries, academia, technical sector. I'm Cila Pesniak and I would like to introduce the ENEN2 Plus project. It is about the building European nuclear competence through continuous advanced and structured education and training actions. The ENEN2 Plus stands of the largest and most integrative nuclear education and training efforts up to date. Attraction of excellent new talents followed by outstanding development through education and training, cross-cultural and cross-disciplinary activities are the overreaching objectives. A detailed insight into the European Union's supply and demand of nuclear human resources for power and non-power applications will be developed. This will include industries, academia, technical safety organizations and regulators. High number of nuclear talents will be achieved through dedicated career-related events and competition for high school pupils and teachers, students, postdocs and lifelong learners. A strong mobility program will support over 100 person-years of nuclear career-enhancing experience to about 1,000 learners with over 2.5 million euros. Cross-border and cross-disciplinary mobility within and beyond European Union will be promoted in cooperation with Joint Research Center, OECD, NEAM, and partners from USA, China, Canada, Korea, and Japan. A single hub will be established to provide information and available education, training, and job opportunities. I would like to introduce European Nuclear Education Network. The Budapest University of Technology and Economics was one of the founding members of the ENEN. It is an international non-profit association within 20 years of experience. Mission are attraction of new nuclear talents, preservation and further development of expertise by education and training, cross-cultural and cross-disciplinary activities supporting safe, competitive and sustainable use of nuclear technologies. The ENEN has 89 members and the fields of expertise are nuclear energy, engineer, technology, safety, safeguard, management, radiation protection, medical physics, nuclear chemistry, radioactive waste management and geological disposal. The ENEN2 Plus project is a continuation of the very successful NN Plus Horizon 2020 project. In this project, we have 39 directly funded partners, 51 partners in total, including international organizations and extra-EU partners, partners from Europe, North America, and Asia. The project consists of 8 work packages, including project and data management, and the total estimated budget is more than 7 million euros. The BME is the leader of Work Package 3, Enhancing Nuclear Competencies, Continuous Education and Training Programs. This year we organized 2 competitions. The first one was ENEN PhD Event and Prize in Krakow, 10th of May, and the second one will be third European Nuclear Competition for Secondary Schools. It will be organized by our university on first week of July. We received more than 50 applications and we hope that it will be a very fruitful and successful event. We would like to compile online scientific professional bulletins introducing each nuclear professions and technological novelties. 4 bulletins per year are planned. We are looking forward to receiving interesting articles, events, programs, reports, interviews related to nuclear professions and science. High quality and non-proprietary education and training are essential for all sustainable nuclear power and non-power programs. They require universities, training organizations, industry regulators, and governments in some countries to work together in the longer term to ensure the quality and quantity of the workforce. Challenges and further needs strategic strengthening of academic and vocational education and training programs for nuclear professionals, facilitating multidisciplinary or cross-disciplinary approaches. Continuity facilitated by European projects will be needed. ENN2+, with its members, is well prepared to take the lead by this comprehensive nuclear education and training knowledge management program. Thank you for your attention.
Talking about another advanced reactor project. This one is called SAFEG, which stands for Safety of Gas-Cooled Fast Reactors Through Innovative Materials, Technologies and Processes. And so to start, what is this gas-cooled fast reactor? Well, altogether there are 6 different promising advanced reactor technologies supported by the Generation 4 International Forum. And so each of them focuses on the most important challenges of nuclear energy. And one of these is gas-cooled fast reactor, GFR. Its main advantage is that it offers very high core outlet temperatures, which allows for high efficiency electricity production, and also the possibility to close the nuclear fuel cycle by using significantly, or creating significantly less nuclear waste than current reactors. So the reactor here is called the Allegro reactor. It is supposed to be the prototype for this GFR technology. Its point is to demonstrate the viability of all the technologies connected to GFR. It's been under development for about 15 years, and in the last few years, it is under development mainly by the V4 countries, together with France, the UK, and Japan. And our current project, the SAFEG, received 4.5 million euros of Horizon 2020 funds. And so here, the most important conceptual questions are already answered. So the current project focuses on the aspects of safety through 3 different areas. First is material science, where we try to develop advanced materials that can withstand the high temperature and high radiation for a long period of time. Also, some of the tasks are focused on the fuel cycle and the proliferation resistance and sustainability of the fuel cycle. And of course, the engineered safety systems themselves. Most importantly, the development of a fully passive decay heat removal system and the development of a reactivity shutdown system. So what is the contribution of our institution? Well, we employ 4 different research methods. First of all is the system thermal hydraulic codes. We use a software called APROS to analyze the transient behavior of the system. Here our task within the project was to improve the design of this decay heat removal and to optimize the general transient response during accident scenarios. We also have a particle image velocimetry laboratory where my colleagues have conducted a number of experiments to help with the validation of our computer codes. And we also organized a CFD benchmark activity for all the participants of the project. Next, we employ quite a bit of CFD modeling in order to analyze the detailed temperature distribution of the fuel rod bundles. And here, my colleagues have made significant improvements in evening out the temperature distribution within the fuel by introducing little fins and vanes onto the spacer grids of the fuel rod bundle. And very interestingly, combining these three methodologies is very useful within our latest research effort, which is to develop a more accurate method of heat transfer calculation for this APROS software. And to do this, we are highly relying on the CFD and PIV measurements. And last but not least, our reactor physics department uses Monte Carlo methods for optimization of the neutronics and the reactor shutdown system of the core. And yeah, that concludes my brief introduction to SAFEG. So thank you very much for your attention.
My name is Victoria Feigl, and I would like to introduce you the research group of environmental microbiology and biotechnology. Our group is working at the Faculty of Chemical Technology and Biotechnology at the Department of Applied Biotechnology and Food Science. This is basically our group. It is led by Dr. Monika Molnár. And our main research interests are in environmental risk assessment of chemicals and the characterization of chemicals and contaminated sites. And our main methods to do it is environmental toxicology and environmental microbiology. In environmental toxicology, we use small test organisms. You can see them on this banner to predict the effect of chemicals on the ecosystem. And we have some interest in nanomaterials such as nanotitanium dioxide and nanographene oxide. We started to use recently. So basically using this methodology, products, waste, and also the chemicals applied mainly in the chemical industry. And we also work on an interesting area of microbiology, which is microbial communication. So how microbes interact with each other. And actually we can influence this communication by adding certain molecules. And this could be really important in certain areas, like to prevent biofilm. We work on the development of soil remediation and amelioration technologies. We usually apply waste and waste-derived products for these purposes, so to go towards the zero waste concept, such as biochars, also called red muds, and fly ashes. That's been operating for quite a few years now. We have participated in two H2020 projects. One was the Electra project. It's ended last year. And this was basically our colleagues developed groundwater and soil remediation technologies for all kinds of contaminants with bioelectrochemical methodologies. And we used ecotoxicology assessment to follow up the performance of these technologies to prove their environmental performance. And another interesting participation was the SCALE project, led by a large alumina factory in Greece. And they produced scandium from bauxite residue and also titanium dioxide waste. And we used, again, environmental toxicology and environmental risk assessment to follow up their processes. We have also participated, of course, in several national and international projects. And I'm happy to share, and we are quite excited to start a new project this year. This was funded by an EGP Soil International call, and we will use biochar composites for soil treatment. And we just recently got the news that we will also participate in a Marie Curie staff exchange project where partners develop technologies for basically emerging pollutant contaminated waters. We are quite open for collaboration in new projects, in environmental monitoring, ecotoxicology, environmental risk assessment, and also technology development for soil and water, contaminated soils and waters. And I have enlisted some of the horizon calls that we are happy to cooperate in soil treatment, water treatment, waste reuse. And thank you for your attention.
Welcome, my name is Dr. Richard Weber. I am from the Faculty of Mechanical Engineering and Department of Hydrodynamic System. And today I will speak about the hydraulic and biological modeling of water distribution network. As you may know, the water distribution networks are one of the key infrastructure elements of every modern settlement, providing clean, safe drinking water to the inhabitants and the industrial consumers. For a model, we need a hydraulic model first. We are using GIS data, Geographic Information System, to build a topology. We add the pumps and tanks and active valves to the model. We do some corrections to the database. And finally, we add the demands to the model. And if we are lucky enough, we will get something like this, that is a model for a real-life water distribution network. To solve the equation, we need the hydraulic solver. We have an in-house solver that is called Stazzi. It is developed by the department. It solves the edge equations and equation for the nodes. And as an output, we can get the pressure and the volumetric flow rate. This software is freely available. It is open source on GitHub. Let me speak about the vulnerability. What happens if we have a pipe burst? For example, here we have a little toy network, and we have a pipe failure. Then the corresponding utility company must shut down this segment, this island, by closing valve B, D, and E. And the question is, which segment is more important than the other segments? We need two metrics. First is the relative failure rate that tells us what is the probability of having a random pipe failure at the segment. We can use pipe material data, pipe length data, etc. And the other metric that we need is the relative consumption outage, which is why we need the hydraulic model. It is also a number between 0 and 1, and it tells us, in case of a random pipe burst, how much water is not served during the reconstruction. And we have two metrics. The local vulnerability is, by definition, is the product of the two. So this means that the segment is vulnerable if there is a lot of pipelines, and in case of an isolation, there is a large outage. And this way we can, for example, plot or colorize the network by this metric, and we can identify the segments, the areas which are more important and where the corresponding utility company must be aware of any pipe burst. This is another example. Let me speak about the water quality modeling. The quality of water is very complicated. It depends on residence time, chlorine concentration, temperature, pipe material, the initial quality of the water, and then many others. Our approach is to build a model that can predict a qualitative distribution in a water distribution network. The question is which areas might be sensitive in terms of water quality. For this, there are mathematical models already developed in the literature that describes the biofilm growth and detachment and the substrate transport and diffusion. But the problem is that these mathematical models typically contain several parameters which are really hard to estimate, to predict. That's why we built a laboratory measurement that is a semi-real life water distribution network. And with this measurement equipment, we would like to adjust the mathematical, we would like to calibrate the mathematical models, and then with the correct parameters, we can introduce these mathematical models to the hydraulic solver, and that can predict the sensitive areas in the water distribution network. Thank you for your attention.
Thank you very much for your attention. I would like to thank all of our presenters. I would like to thank everyone in the room and everyone who was following us through the live stream. We would like to thank you for your attention and would encourage you to visit our YouTube channel, the BME FIEK, which is F-I-E-K YouTube channel, where you will find the videos. And we would also like to encourage you to visit the BME competence map, competence.bme.hu, where you will also follow the videos at the researcher and the research group profile pages. Thank you very much. We look forward to cooperating with you.